Quiet on the set. Quiet on the set. Example 8, for speeds between s equals 30 and s equals 75 miles per hour, the stopping distance is given by this equation. And so it says find the actual stopping distance. Let's use this pen right here. Actual stopping distance at 65 and 66. Okay, so I want to find f of 65 and f of 66. And then it says, okay, what is the stopping distance needed for an increase in speed by 1 mile per hour? So it's just going to be the difference in those two. So I'm going to find those two in the calculator, and then then after that, we're just going to subtract them. So whatever f of 66 is minus f of 65. And you're probably like, what's the point here? Well, this is kind of like the linear approximation stuff. Like anything close by to the moment that we're talking about can be approximated using a linear function. But they're saying of a difference of 1 unit. Okay, and that's what the top part of your notes is talking about. All right, so here we go. I got to go hand calculator here. So 65 plus 0.05 and then times 65 squared. And so the first one, I got 282.75 feet. This is in feet. Yes, it is. Feet. And then on the second one, let me change my 65s to 66. And I got 290.4. All right. And then it says, okay, what's the stopping distance needed for an increase? Well, that's the difference in those two. So I'm going to take the 292.4 and I'm going to subtract out 290.4, sorry, minus the 282.75, and I've got 7.65. Okay, so then, all right, so now let's break into some calculus then. So it says, estimate the change in the stopping distance if the speed is increased by 1 mile per hour by using the instantaneous rate of change at 65. Okay, so in other words, we want to find f prime of 65 and see how that compares to this. All right, well, f prime of s is our variable, is going to be 1.1, all right, plus power rule 0.1 s. All right, so f prime of 65 then, oops, lost my parentheses, is going to be 1.1 plus 0.1 times 65. And that's 7.6. How about that? So it's pretty close to the actual amount that was needed to move up 1 mile per hour. It was 7.6. And that's in feet. Okay, so then part C then says, all right, compare this to the actual increase. All right, so the difference is very small. So it is that the difference is 0.05 feet is the difference between those two. All right, so again, so a very, 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 very small amount as far as the difference goes. And so that's kind of the point there. The point is, using that instantaneous rate of change is very, very, very useful whenever you're close by. And in this case, they're saying by a 1 unit change. All right, so I like that the derivative is very, very close to the actual difference in those two amounts in a 1 unit change. All right, so that's it.